Today's lesson, we're going to be dealing with Euclidean Geometry. However, before we get to grade 10 Euclidean Geometry, we need to do revision of grade 8 and 9 work. Why? Because it's absolutely essential, or it's absolutely imperative that you get to have the basics of Euclidean Geometry before you approach grade 10 work. Likewise, this video, not only is it helpful to grade 10s, it's also helpful to those who are doing grade 11 as well as those who are in their Matric years. Why? Some of the things that you're going to learn in this video, or the revision or reminders, can be used as answers in your grade 10, 11 or Matric work. Alright, without wasting any time, let's start. So the first thing that we're going to learn about, it's going to be about straight lines. Now, if we give you a straight line like this, you know that this angle on a straight line, you get 180 degrees. It's also referred to as what? A straight angle. Now, what if we are now provided with what? A straight line, and then it's divided into two parts, meaning to say that you've got this angle here and you've got this other angle there. Let's call this angle A and let's call this angle B. Now, these two angles, where are they located? They are located on a what? On a straight line. And we have been told that on a straight line, how many degrees do we have? 180 degrees. So it essentially means that when you take your angle A and you add it with angle B, then these two angles, their sum is 180 degrees. Now, angle A plus angle B is equals to 180 degrees, and these two angles, they are known as supplementary angles. Supplementary angles. Right. Now, let's move on to the next one. We're still dealing with straight lines. Now, in this particular instance, you're given a straight line. However, it has been partitioned to three different angles, meaning to say that here I've got this angle, then I've got the other angle and the third angle. Therefore, we've got angle A, angle B, and angle C. Now, when you're having three angles like this, remember their location is what? A straight line. So we say angle A plus angle B plus angle C. Their sum is still the same. For those who do not know what sum means, it simply stands for what? The answer you get after adding. That's what is called a sum. S-U-M. Alright, so now these are no longer known as supplementary. Supplementary is when it has been divided into two. Now when you've got three or more, this is what is known as what? These angles are known as angles on a straight line. Angles on a straight line. All right, so that's what we have. Now, I want you to observe the next type of lines that I'm going to give you. Now, I'm going to have this one. This line, I know that it gives me 180. Regardless of how slanted it is, at the end of the day, it's still a straight line. Then if you are provided with another straight line, now they are intersecting here. I've got the first straight line, I've got a second one. Now, which means that I've got two straight lines. Remember, an individual straight line gives you 180 degrees. When you have joined the two of them, you've got 360. So I'm saying that around these points, 1, 2, 3, 4, you're having what? 360 degrees. But observe, these are what I call kissing angles. Why? Because if you look here, the top part, and if you look here at the bottom part, these angles, where they are intersecting, where they are meeting, it looks like a kiss. Now, these angles, what you're seeing here, this is what is known as vertically opposite angles. Vertically opposite angles. What does that mean? It means that this side is opposite, this angle rather is opposite this angle. So we are simply saying that if this is angle A and this is angle C, angle A is equal to angle C. Why? Because they are opposite each other. Then remember, in Euclidean geometry, when you are going to be proving your angles, they always ask for a reason. So don't give us an answer only without a reason. If you give us the angle without the reason, you get half a mark. All right. So now, these vertically opposite angles, you write it like this as a shortcut because it's rather lengthy when you write the word vertically. So you write VERT dot OPP. Then to represent angles, you draw this and then you do this. This represents vertically opposite angles, acceptable by the examiner. Then these other two which are left, it means that these remaining angles are what? Angle B, angle D. They are equal. So angle B is equal to angle D. And the same reason applies, vertically opposite angles. So that's what happens. So far what have we learned? We've learned that on a straight line we've got 180 degrees. We've learned that here we've got supplementary angles. We've learned that here we've got angles on a straight line. And here we have learned the fact that we've got vertically opposite angles. From there, we are now going to teach you about what? When you are provided with 90 degrees here. If you're provided with 90 degrees here, please forgive my drawing, And now we divide it into two. We've got this angle at the top, we've got this angle at the bottom. Now, when you have divided, or when these two angles add up to 90 degrees, we say angle A plus angle B, they are equal to 90 degrees. This is the first variant. The second variant, you could be having what? You could be given a triangle here. But what type of triangle? A right-angled triangle. Then it's named triangle ABC. Meaning to say that this angle which is here, this is angle B, and there we have got angle C. Now, remember, when you add up the sum of interior angles of a triangle, they add up to 180. Meaning to say, when you say angle A plus angle B plus angle C, they add up to 180 degrees. But now, we were speaking about this 90 degrees, and we said that when you have partitioned it, when you have divided it, angle A plus angle B, it is equals to 90 degrees. What we have here, this is what is called complementary angles. Complementary angles. So, what is the relevance of this example of this right angle triangle? Observe here, angle A, because here this is right angle, it means there is 90 degrees, which means where there is angle A, I'm going to substitute and write 90 degrees. But I still do not know how many degrees is angle B. I also don't know how many degrees is angle C. But I know that altogether when I add them, they add up to 180 degrees. Now, 90 degrees and this 180 degrees, they are like terms. So I'm going to say that angle B plus angle C are equal to 180 degrees minus this 90 degrees here. Right? Now, when I say 180 minus 90 degrees, I get what? I get 90 degrees. So therefore, I can conclude here that angle B plus angle C are equal to what? To 90 degrees. Now, here comes the absolute part. We are saying that when you have got this angle B and you add it up with angle C, these two, they add up to 90 degrees. Meaning to say that these two, angle B and angle C, these are complementary angles. And when you are studying your trigonometry, if you have watched my trigonometric video, grade 10, I've said that then we know them as co-ratios, because these co-ratios are coming from what? Complementary angles. So, yes, that's what we have. This is a reminder of the work that you have done so far in your high school. Right? Okay. Now, from there, What were you taught? You were taught about what? Fun angles. You were taught about parallel lines, and the fact that the moment you have got parallel lines, then you welcome what we call fun angles. So what are we going to do? Let's meet on the next video where we now delve into parallel lines, and then we talk about these fun angles in detail. All right, don't forget, please subscribe, share with your loved ones, like the video, don't just watch it, so that YouTube can recommend other people that you do not know who are seeking help just like you. Also comment if there are improvements which you would like, or if there are topics that you would like me to address. Let's meet on the next video.